I welcome all the dignitaries on and off the dais, faculty members and students for the lecture series organized by Mehsana Urban Institute of Sciences, Ganpat University. We have the distinguished speaker for today's session, Dr. Kumar Bhatt, eminent scientist from USA. We also have with us Dr. Amit Parikh, Principal, MUIS. Now, I would like to request Dr. Amit Parikh, sir, to welcome Dr. Kumar Bhatt, sir, with bouquet. A big round of applause, everyone. Thank you, sir. Now, I would like to invite Dr. Amit Parikh, Principal, MUIS, for the welcome address.
Good afternoon. Respected invited guest, Dr. Kumar Bhatt, Bikesh Bhai, dear faculty members and dear students. I welcome all of you to this expert lecture. Today is a special day for all of us. We are celebrating our annual day, Synergy 2019. And as a part of annual day celebration, we have arranged this expert lecture. First of all, I would like to thank today's expert, Dr. Kumar Bhatt, for accepting our invitation and remain present here to express his knowledge, to share his knowledge with us. Actually, I approached him just before 3-4 days back. So, special thanks to sir for accepting the invitation in very short notice. And actually, I have invited him for our evening function. So he is a chief guest for today's evening function. Then I took the opportunity that when sir having such a profile with sir, let us have the opportunity to have some knowledge from, let us gain some knowledge from him. So I asked him to deliver one lecture for all of us, and he agreed to deliver a lecture in a very short notice. So thank you very much once again, sir. And the theme of today's lecture is expansion of science and understanding. Vignan ane samajno vikas. So it's a very interesting general topic, and sir is having a vast experience at national and international level. He was a scientist at PRL for 20 years. He worked under the guidance of Vikram Sarabhai, scientist, and when he was a director at PRL. So and then he moved to USA. He is having experience as a scientist, as a professor at various universities of USA and France. So we are fortunate today to have with us such a eminent scientist. Now, not taking much time, I hand over to sir. Please, sir. Thank you.
Movable mic check. We are pleased and privileged to have with us the distinguished speaker, Dr. Kumar Bhatt. Sir is born and brought up in Bhavnagar. Sir has completed his graduation from Dharmendra CG College in Rajkot and post-graduation from MG Science Institute in Ahmedabad. Sir has done his PhD in nuclear physics from University of Chicago, USA. Sir has worked at Oak Ridge National Laboratory, Oak Ridge, Tennessee, USA. Physical Research Laboratory, Ahmedabad from 1964 to 1984. Sir has worked as visiting faculty at Louis Pasteur University and Center for Nuclear Studies at Strasbourg, France, University of Texas at Austin, USA, Western Kentucky University, USA, University of Mississippi, USA. So now I would like to request Sir to come forward for the session on expansion of science and understanding. Big round of applause. Welcome, Sir.
Well, it is it okay? I will use both, so okay. I would like to thank Bikesh Bhai for initiating this visit here. Some time back he asked me to come here. At that time I was lucky to be sick, and so I could tell him that no, I can't come. And then, but he had noted down this rain check, and this time he asked me that you remember that you are supposed to come here, and I had no excuse this time to say no, and so I came over here. But I'm very glad that I came here because I've looked around, went around and saw all the nice things that are being done here. And I'm embarrassed to say that I did not know even the name of this university until he told me about it here, maybe few days ago. Now you just heard that I was invited here just a few days back and asked to give talks, and I agreed to give talks. So you can imagine what kind of a talk it would be. So please excuse me if it is a pretty loose talk, and I will just rumble along, and hopefully there will be some connections. Okay. The title of the talk, which I wanted to give but did not give correctly, is Science and the Evolution of Understanding. Science and Evolution of Understanding. Now, understanding is a very loaded word, which we don't really appreciate. When we understand something, then that understanding itself tells us that there are many things that we did not understand before. And so the meaning of the word understanding itself expands as you understand things. Now that is the way in which science has helped us in evolving our understanding over the ages. So let us start with science. There are, of course, science has existed as long as man has existed, and he has been curious about things. That is how we are all born with. Curiosity is human. But for the sake of concreteness, we can say science began with Galileo and Newton, physics. And then, of course, it led to all other sciences, chemistry and biology and other things. So, what is the aim of physics? So the aim of physics is, in a very broad sense, is to understand phenomena. Anything that exists, to understand phenomena, that's the aim of physics. Okay. So the word is here, new word here is, what is phenomena? What do we mean by phenomena? So a Greek scientist, a philosopher, said that well, phenomena is nothing else but matter in motion, and all else is illusion. Matter in motion, all else is illusion. So the aim of physics is to understand phenomena. That means to understand matter in motion. Now, of course, that does not mean that we don't have to understand illusion. But understanding illusion is not a part of physics, is not yet a part of science. It is a reality. It is the basic reality according to Indian philosophy, that everything is an illusion. But in science, phenomena which is just matter in motion falls under science, and we want to understand that. And that is the aim, that is the part which is related to physics, related to science. I will skip over a lot of history, but all of you are scientists, and so at least connected with science or heard some basic things about science. So I would like to, well, before I come to that, there is another thing. I said matter in motion. That's what I said here. That phenomena is nothing else but matter in motion. So again, two words are there which we have to understand. What is matter? What is motion? And understanding the two, understanding matter and understanding motion, and understanding the relation between them is the aim of physics. Okay. Now, as I said, that what do you mean by understanding matter? Okay. So when you ask this question, immediately you say, well, it is a long tradition for humans to say that, to suspect that what we see, the diversity of things, we see infinite number of different things, but we do not accept that as reality. Human beings have always suspected that there is a simpler reality behind the diversity. Okay. But now, and you want to access that deeper reality, and physics tries to do that. But initially, suppose people said, what is matter? Well, it is all the different forms that we see of matter, infinite number of forms. They are just different manifestations, only 5 elements. Earth, fire, water. So these are the 5 elements. Well, it's okay to say that. Okay. Do we understand matter just because we say they are made of these 5 elements? Do we really understand? Because suppose we say that they are made of 5 elements, there is no problem, we can grant that. Now, if I take a piece of matter and I ask you, and I give you these 5 elements, can you put those 5 elements together to produce these different forms of elements? That is, understanding matter involves 2 processes. One is the decomposition of matter into different constituents. And the second is to see if our decomposition is correct, meaningful. We should be able to put together the constituents to produce the different pieces of matter. So when we say it is made of these things, that means that we are able to separate the constituents. But not only that, we put together, take those constituents, put together, and make up the object that we made. So the aim of studying matter is to separate out the pieces, decompose the matter into constituents, but understand how the constituents are brought together to form the matter. Now that's, of course, a very large program. That is one way, one part. But then there is also, you cannot understand phenomena unless you understand the motion of bodies. But motion of bodies takes place because bodies attract each other or repel each other. Okay? Things don't move about on themselves, they have to act they are acted upon by something else to make them move. So unless we understand matter, we cannot understand motion, because we have to understand how pieces of matter attract each other or repel each other to understand their motion. We cannot understand matter until we can observe their motion. The two are interrelated. The nature of the matter is revealed through its motion. How pieces of matter interact with each other is revealed through their motion. Only when you observe their motion, then you can see, okay, this is how the matter behaves. Then your understanding of matter has increased. Okay. So now, the program of physics has been to understand, first of all, the laws of motion. So all of you must have soon, somewhere along the line, must have studied mechanics, and all of you must have heard of Newton, and all of you must have heard of Galileo. If you have not, you must hear about it now. It's good, never late to learn about these two great men, okay? Galileo and Newton. And so there are three great laws of motion. First law says a body in motion continues to move in a straight line with constant speed. A body in motion continues to move in a straight line with constant speed. That is the first law. Now this can never be tested. It's very simple, but continues to move, how do we check? Because it will take an infinite amount of time and so on. So it is something which is tested over limited distances. But the second law says that if it doesn't continue to move in a straight line, then there must be a force acting upon it. And the force is equal to the rate of change of its motion. So that's how the two laws are defined. So I want to, then this is the basic law, force equal to mass times acceleration. It's a one equation that I want to write here to really illustrate to you the significance of science. Just a minute. So I need to write that down. Can I write something? Yes. So this is a law of physics, very simple law. Most of you would have seen this. This says force equal to mass. We understand, have some intuitive understanding of what is mass. And this is acceleration. And acceleration is nothing else but the rate at which motion from straight line is changing. Okay, acceleration. Now in this equation is somewhat different from an equation of mathematics. The two just arithmetic equations, 5 equal to 3 plus 2 or 12 equal to 4 multiplied by 3, the two sides say the same thing in these equations. Here the two sides do not say the same thing. This equation is very different from these two equations. Let me explain. This is one force. We have some intuitive idea of what is force, something which we can use to make bodies move. Now, if the only way of knowing F is to take mass and measure the acceleration, take the product of these two, then we have learned nothing new. Okay. Now, this is very different kind of a behavior. Where is phenomena in this equation? Phenomena is matter in motion. So where is motion here? Motion here is in the acceleration. This is the rate change in motion. So that is where the motion is. This is the real world. This side of the equation depicts what we see. It is the phenomena. That is something that is happening in the world. What is this? F. F is not in this world. You have to imagine. It is a part of mental construct which says you have to find this by thinking. And Newton says that you can find that such a thing so that you can quantitatively predict accurately what the motion is, what the acceleration is. So let me explain this just by one example. So there is the sun and there is the earth, and we know that we are going around the sun. We know it takes 365 days and so on. We even know the orbit of the earth. How does the motion? So motion is not in a straight line. Motion is in a circle, and therefore there must be a force acting upon it according to Newton. So force equal to mass times acceleration. So acceleration we can observe. That is what we see in the orbit. We can observe the acceleration of the earth around the sun. But what is the force? Some of you know what the force is. What is that force? Force is proportional to mass of the sun, mass of the earth, divided by the square of the distance. That is the formula which Newton wrote down. Now, do you see any motion here? There is no motion. Numbers here, this is thing. Newton didn't know, he just guessed that if this is the force, he said maybe this is how it is. He guessed that if this is the force, then how would a body move under such a force? And then he could actually reproduce the motion of all the planets, not only of the earth around the sun, of the moon around the sun, but all the planets, he could reproduce the motion. So what I want to say is this force in the force equal to mass times acceleration, that force is a mental construct, comes from the human mind. And the equation says that what happens in your mind is recreated out in the world. You can predict with what you imagine in your mind, with this law of motion, you can find a correlation between your imagination and the actual happening in the world. And that is the beauty of the physics, laws of physics. The law of physics says you observe the phenomena around the world. But in order to understand that phenomena, you have to construct, you have to have mental constructs of what might be happening between the pieces of matter. It is not given to you. You cannot observe that. The mind has to create that mental construct so that with that mental construct and Newton's law of motion, you can understand the phenomena. That means that you can predict how the motion will take place. So when this happened, and when Newton was successful, and when he was successful in predicting the motion of predicting the motions of heavenly bodies, people were very highly impressed that how could a human mind solve the mystery of the divine motion. And so that is how the faith in science started to grow. So what happened then is that with his laws of motion, Newton could then, not Newton, but successors of Newton, all of science flowed from those laws until, of course, we come to the 20th century. So understanding a phenomena now involved finding out this force or the forces which act between different parts of matter so that we can understand their motion. So for example, chemists found out that if water can be decomposed by electricity, you can separate into hydrogen and oxygen. And they could not separate hydrogen anymore, they could not separate oxygen anymore. So these two were different chemical elements. So water is decomposed. If you bring them together, there is an explosion and you indeed form water. So that also we understand. But what we don't understand is how does a molecule, how does a hydrogen molecule, hydrogen atom interact with oxygen? We don't understand. That is not law of gravity. And so to understand, to say that water is made of hydrogen and oxygen is one thing. To involves that you can separate into two constituents. But that understanding is incomplete until you can show that you bring them together, they will form water. That also is done. But what we don't understand is how do they come together? What is the force which binds them together and gives rise to water? Now that question could not be answered in terms of Newton's laws of motion. So here was the thing here, that understanding phenomena meant understanding the world in terms of Newton's laws of motion. The Newton law of motion constitutes two parts. One is this law of motion itself, which relates a force to the acceleration. There is force to the external world, force to phenomena. And the second part is what is the law of force itself, which is purely a mental construct. So we have to find, at the end of the century, it turned out that this Newton's formulation of the law is not quite correct. We need a slightly different law of motion. But the process of finding the force is still a mental construct, and still we have to find that we have to do the guesswork to do that. Let me, of course, and that needed some quantum mechanics, and I don't want to go into that at this stage. But let me go back into phenomena, and let's take phenomena which we detect with our senses. That is what we call phenomena. So one phenomena is sound, another is light. Okay? These are phenomena. So how do we understand them? So sound is, of course, we hear sound, but it is property. I don't know how do we go about understanding what is the meaning of understanding what is sound. The question it is not to be decomposed. There is nothing to, it is not some piece of matter which you can get in your hand and decompose and bring it together. But it is a phenomena. How do we understand it? And how is it related to Newton's laws of motion? So well, none of us have seen atoms, but all of us know that the world is made of atoms. So what? What is the connection between sound and atoms? We have no idea up to this point. So now somebody comes and says, well, the air is there and air is made of atoms, and sound are compressions of air. So air is compressed and decompressed, and these compressions propagate in air. Propagate like waves in a string. If you take a string and give it a jerk, the wave propagates. Similarly, if you compress air, the compression will propagate in the air. This is an idea. This is an idea, it's a conjecture. This is what it is. And then you can go around and try to find a way, if this is true, how do you show that sound is like a wave in the gas, like the density in the fluctuation in the density of the waves. So there are experiments which people do here in the lab here, which actually visualizes the compressions of the air by putting some dust particles and showing that they form standing waves, and you can show that sound is forming waves and so on. Except that we can never see a wave moving through this sound. That's fine. So we understood the phenomena of sound in terms of matter in motion. Phenomena of sound, matter in motion, so atoms were there, they are getting compressed, they move, and that is how the sound is produced. The problem here is, which is always there, sound, I'm speaking, you are hearing the sound. Does the air in which the vibrations are propagating, is it hearing the sound? Is there a sound in the air, or is there a sound only in the brain? What are we trying to understand? We are trying to understand sound. Sound is something that happens in our brain. What we have explained is sound is what as it is propagating in space. So the question is then, when do we say we understand sound? Part of it we understood when we described it in terms of waves in matter. The other part, that sound is what we hear, we do not know, we do not understand why we hear what we hear. Okay, on one side we understand that if the waves oscillate very rapidly, we hear a very shrill sound. If they oscillate slowly, we hear a low sound. All that we understand. But why do we hear? That we do not understand. So you go back to one of the old Upanishads. Kena Upanishad starts with a question. So there is a question, I do not know Sanskrit, but it says, by whom willed does the mind settle on the object of its thought. So we are thinking about things, but something else is making us think. And who is that? We don't know. So here, we don't go that deep. We are just remaining still outside. That even though we could explain sound as motion of atoms, motion of atoms, compressions of waves and so on, we cannot really understand the phenomena of sound as experienced by us. Okay? There is still no, of course we can go into the ear, we can take the sound wave coming in, going into the tube, we can dissect the ear, we can see what the sound does, we can look at the engineering and marvel at the engineering of the ear and how that sound propagates through that, how frequency